All right, here we got 24 hard SAT math problems. These will come up again and again in Module 2. If you're aiming for a high score, you need to know every single one of these and you need to be able to do them really efficiently. Let's go through each one. All right, first one here. You got to be able to recognize some of these, right? Right off the bat, I know this is a discriminant problem, right? So how do I know it's a discriminant problem? Well, you got a quadratic. It's telling you how many solutions you have, right? And we're going to be asked to find like an unknown. So that's a discriminant one. So you got to know your discriminant part of the quadratic formula, the part that's inside the square root, right? So know your cases, 2 solutions, 1 solution, no solution, right? So here they're telling us that it had no solution. We just need to type this into Desmos, right? The great thing about this one, it's already in our, standard form. We can see A is -1, B is B, C is -400. Go over here to Desmos and just type that in, right? -4 times the A times the C, and then less than 0. Desmos won't show it to us yet because remember, if you have an inequality or equation, your unknown should be X, right? So switch this to X and you see now it's gonna show me very nicely all the values of B, right? That will give me no solution. And what's this question want? It wants to know what's the greatest possible value for B. That's gonna be 39, right? It can't be 40. You can click on it, but can't be 40, right? That's a dashed line passing through it. So 39 is our answer. That's it. Next one. Which of the following are solutions to the given equation, right? So here's something you got to know about Desmos. It's, you don't have to know how to solve any equation. If it asks you for solutions, just type that in, right? This is going to save you time, save you headaches, right? Make your life easier. So right off the bat, and this is why it's a hard one, you don't get solutions right away, right? You got to kind of understand what Desmos is telling you. If you see this triangle here, it's an error, right? Why do we have an error? You have an error because it doesn't know what A is, right? What do? Well, we just tell it what A is, right? So how do I know I can do that, right? Well, it depends, right? Sometimes you can, sometimes you can't. If the question's ultimately not like, what is A? Generally, you can just plug in whatever you want for A. They might give you a condition sometimes. So here, it's telling me as long as A is greater than 60, so I'll go with 65, right? And you see, once I do that, the error goes away. I see my 2 solutions. Let me see what they are. So usually you can click on them. Yeah, here I can click on them. So 51 and 66, right? So what's my answer? Well, definitely 51, number 3. And how about the 66? Well, that depends on A, right? A was 65, so Roman numeral 2 here would represent 66, right? So we got 2 and 3 only, right? Next one. Conversion problem, right? This one especially comes always at the end of the test, right? They're gonna have something with units squared, right? And people mess this up. So let's take a look at our conversions, right? You got to just be able to do basic dimensional analysis, right? Here's a simple example. This example doesn't have units squared, but it's the same idea. Just make sure you line your units up correctly so that things cancel out and you're left with the units you need, right? So let me show you this in Desmos here. So 8.2 meters per is your keyword for division, and it's 1 second squared, right? So what that means is it's like this, 1 second squared. So what am I going to do? Well, let's first change from meters to miles since they go to that conversion, right? They'll give you pretty much everything but really basic ones, right? So they're kind of nice about that. So it's 1 mile over 1609 meters. You see here, meters would cancel out, so we're all good. Next, I got to change from seconds squared to minutes squared, right? So here's where people mess it up, right? Well, obviously it's 60 seconds to 1 minute, right? But if you just leave it like that and you see they'll have a trap answer, I'll kind of write this out. I'll multiply this out for you. If you want Desmos to do the work, just, write it without the units. I have the units there just to make sure I line everything up correctly. But you see, this is the trap answer, right? Why? Because this was seconds squared. This is just second. How do I fix that? Well, it's simple. You just square it, right? So I would have this in parentheses with a square, and you see this is the correct answer now, right? So 18.3. Next one. In the given system of equations, R is a constant. If the system has no solution, what is the value of R, right? So let's take a look. So you got to know these, no solution, infinite solutions, right? And if we're looking at it on a graph, which we could do to answer this one, I'll show you that, or we'll do it algebraically. If you're looking for it on a graph, you just need parallel lines, right? These are both linear equations. I know they're linear because none of them have exponents. That's the easiest way to tell something's a linear equation. So I just basically want them to be parallel, right? And parallel is just going to mean same slope, different y-intercept. That's how you can do it algebraically, right? You just got to find their slopes and, equal them to each other. But there's a cool thing you can do in Desmos as well that I'm going to show you here, right? So if I just type this in, it'll draw the first one, right? But it won't draw the second one. Why? Because it doesn't know what R is, right? So here you can use this tool. It's a pretty cool tool. The slider, right? You might be familiar with this. What I like to do with the slider, you see, it'll just set the value to R to be 1 so it can graph it. And then you can move the value. And what do we want? We want them to be parallel, right? So it looks like right about there. Typically, this one's always an integer one. That's why I like to try with a slider, because you're not going to usually get like a really weird decimal answer. It's always like a whole number from all the problems I've seen, right? So sometimes it's worthwhile to just try with a slider like that and see if you can find it pretty quickly, right? So 8 is correct, but let me show you how you can do it otherwise, right? Otherwise, you just got to solve these for their slope, right? So we got to have them in slope-intercept form. So the first one over here, just kind of rearrange it. I can add 10 to this side. Actually, let me just kind of write it down here. Subtract 20, 15y, so it'd be 20x plus 10 equals 30y. And then we just divide by 30, so it'd be 2/3 x plus 1/3 equals y. That's one equation. This other equation, also pretty easy. Subtract the 2, so it'd be rx minus 2 equals 12y. And then divide by 12, right? So we're going to get r over 12x minus 2 over 12. I can write that as 1/6. That part actually doesn't even matter. But this is it. But you see now I have this slope and it has to equal this slope. So basically I just got to solve this. 2/3 has to equal r over 12, right? When you use the variable r, Desmos draws a circle, so ignore that. And if you want Desmo to solve it, remember, just make it x, and there it is, right? You can click on it and it's just 8. So both ways are great. So whatever you prefer, but the slider is a pretty cool one to know there, and it always tends to be a whole number from what I've seen. So that's it. Next one here. This is a classic question. Everyone usually messes this up. Again, this comes at the end of module 2. People think this is a lot easier than it is, and they just kind of mess it up. If you read this and if I just ask you to read this and pick an answer, probably, people are going to pick one of the ones with plus 280, right? And that's going to be a trap answer, right? The reason is it sounds like it should be the y-intercept because we think of that as the initial amount, but that's not the initial amount, because the y-intercept is when, x is 0, right? But here x does not, is not going to be 0 at 280, because x is the number of hours, right? They tell us over here, x hours. And so that's 2 hours is 280, right? So honestly, a really simple way to do this is you can mentally just plug in 2 for x and see which one gives you 280, right? So it can't be B, right? And it can't be A, and it can't be C, right? So it's got to be D, right? And like I said, you can do that mentally. 2 times 125 is 250, plus 30 is going to give you 280, right? Here's another way you could do it though, right? These are just linear equations. So you just give Desmos 2 points and it'll give you the linear equation. But that requires you to understand what's x and y. We talked about x, hours, y is the cost. So you see, that's 1 point 280, and then they give you another one, and you just smash the regression button, and there's your equation as well, right? So plug it in or, use the regression. Next one here, we got a circle, right? Circle with this radius of 5, right? So for this one, you want to know your circle equation, right? Here it is. So you should be familiar with this. Sometimes you need it. Sometimes you can get away with it because you can just put it in Desmos, but something like this you can put in Desmos. That's what makes it a hard one, right? So just plug in our center for h and k and plug in r. So let me go ahead and do that. It'd be like this: x plus 2 squared plus y minus 7 squared equals 5 squared, right? So I can just make that be 25, right? There's our circle. They want it in this form, right? Which is just the expanded form. So you got to kind of square things. So just make sure you FOIL correctly, right? You should know that y squared minus 14y plus 49 equals 25. And finally, what do we got to do? We just got to set it equal to 0, right? So if I write it the way they have, you see x squared plus y squared, and then it's going to be our ax, which is 4x, and then plus by, which is minus 14y. And then this is it. We got our c is going to be this: 4 plus 49. That's 53. 53 minus 25, right? So we just do that. Just make sure we get our math correct. So 28 equals 0, right? And that's it. The question's about C, right? It could be about A, B, C. It could even ask you like what's A plus B plus C or whatever at the end. It just wants to know C. So now we know that's 28. We're done. We move on. Next one. The regular price of a scarf is $22.40. The sale price is 75% less than regular price. All right. What you got to do here, it's percent, right? Here's a good, cool equation to know, right? You want to basically be able to translate these percent problems into equations. This is just a typical one you can use, like the final value is equal to the original times 1 plus or minus r, right? So you can use this to, kind of like set up different equations and find the missing piece. You can find the final, the original, or the percent, right? So over here, tells us regular price is $22.40, right? So read one sentence at a time, keep all your information. Next sentence is describing an equation to you, right? So it's right here. It says, highlighted, sale price is 75% less than regular price, right? So if I write that, it's going to be like this. The sale price is 75% less, 1 minus, you can write it as a decimal if you feel comfortable. If not, then just, you know, you can always write whatever the percent is over 100. That'll do it too, right? So if you're comfortable with the decimal, it's probably faster, but that's it. And then times regular, right? So you see, I just wrote an equation, right? And what do I know from the first sentence? I know the regular. So you see, I can now calculate the sale price for this, right? So if I do 1 minus 75 over 100 times the 22.40, this is my sale price, right? So now I know my sale price is 5.6. I keep reading, and this second sentence gives me another equation. It says sale price is 40% greater than the store cost, right? So once again, sale price equals, I didn't mention it before, is like your super important keyword when you're translating, you know, word problems into equations, right? Is your equal. So sale price equals 40% greater. Now we do 1 plus 40 over 100, and then it's times the cost, right? So now the final thing, it wants us to do the cost, right? So what's going to be the cost? It's going to be just really, this is going to be a sale price divided by 1 plus 40 over 100, right? And we know the sale price, right? It's this, it's 5.6, right? So I just got to get rid of all of this cost equal stuff for it to display the value. And it's going to be this, just $4, right? The mistake people are going to make here is that second equation, right? That's what's going to trap people, right? So you cannot do the opposite, right? If it says 40% greater, a lot of people are going to think we can write 40% less. That's a mistake. You can't do that with percents. Don't be that guy, all right? So that's it. Next question. Wants to know, basically just gives us a table of values and wants to know what's the correct equation. Pretty simple, right? So here's what you do. Already did this before. Just do a regression, right? These are all linear equations. So if I type this in, negative S14, 2S8, and 5S2, right? Obviously, it's not going to draw anything. It doesn't like that. We don't know what S is. We countered this before. You can just tell it. So I'm going to go with, like, let's make S be 3, right? Don't use 0. Don't use 1. Weird things happen with that, right? Don't use numbers you see here either, right? Like, I wouldn't use 2. Sometimes a weird thing can happen because of that. Anyways, now you see points are plotted, right? I want to know what's the correct equation. I wouldn't do a linear regression here. You could, right? You see, does this help me? This doesn't help me, right? Let me get rid of that. What's the better way to do it? Well, just plot these equations then, right? It seems silly after the fact, right? Once someone tells you, but you see, I know that's the wrong equation, A, because that doesn't go through the points, right? So next one, Sx plus 2y equals 12s. That doesn't go through them, right? That's not it. Next one, 2x plus sy equals 12s. That's it, right? You see, it goes through all the points. That's my correct answer. You see, I can change the value of s. The points are always on the line, right? Next one, equivalent problem, right? These are great. You know, you don't need to do algebra for these, right? These are kind of silly, but they're great. Equivalent just means whatever they give you here has to match one of the answer choices, right? The way I like to do it, because it makes, you know, you can't get it wrong if you do it this way, right? And I'm all about that, right? Doing it in ways that you can't get it wrong. So if I just type this in, you see it gives me a graph. Now, one of these has to give me the same exact graph, right? So all I got to do is like, let me enter in answer choice A now, right? That's it. So I enter in A, boom, there it is. You see, if I click on this green color, it turns it off. I see the blue one underneath it. A is my answer. If that wasn't it, I just kind of go through the rest, right? Those are freebies. All right, next one. Gives us this situation, k and n are constants, n greater than 1. Equation has no solution. What's the value of k? All right, we kind of saw this earlier, right? Just in a different format, right? This is why this is so popular. No solution, and they're lines, right? How do I know they're lines? Again, no exponents is linear equations, right? So they're just telling me that these are parallel lines, basically. What did we talk about? We already talked about that before. They got to have the same slope. Here, Desmos isn't going to help you. Unlike the one we did before with a slider, this one you can't do with a slider. It tends to be like a pretty weird number, right? So here's why, like I say, you still have to know this situation, right? Where, you know, no solutions for lines is going to mean they're parallel. It just means they're going to be the same slope. That's all you care about, right? They're not going to ask you about the y-intercepts because, you know, the y-intercepts can be anything. It just can't be the same number. So like n literally we can't pick n so that this ends up being positive 5/4, right? So they won't ask you about that. And anyways, we can see the slope right over here. It's k over 3, that's your slope. And then on the other side, it's negative 22 over 21. this is it. We just got to solve for k, right? If you want Desmos to do it, just make it x. Boom, I can kind of click on it, right? Otherwise, you can go ahead and just, you know, divide by 3 or sorry, multiply by 3 to both sides, right? So if I did that, you see it'd be like negative 22 over 7, and we can see that's the same number. That's the approximation for pi, actually, right? That's pretty interesting. So let me just type that in there. So negative 22 over 7, got it. Next one, give an equation, k is a constant. The equation has one real solution. What is the minimum possible value for k? This is another discriminant problem. This one is a little harder to tell it's a discriminant, right? The first problem we started with, what is the discriminant problem, right? It was obvious, quadratic, right in your face, right? This one's not. But if you were going to solve this, right, what would be the first thing you would do? You should square both sides, right? And because of that, that's going to be what makes it turn into a quadratic on this side, right? So it is going to be a discriminant problem, but that's how they make it a little harder, right? They can be kind of disguised like this, right? So let me just go ahead, type this in. I'll show you all my work here. So you see, I would square both sides. It would look something like this if I was going to square both sides. So we have this. Then it's k minus x over here. That'd be 50 times 50. That's 2,500 minus 100x plus x squared. And then just like before, we want to set it equal to 0, right? So I'm just going to move the k, move the x. It's going to be 0 equals x squared. And if I add x, it's going to be negative 99x. And then be 2,500 minus k, right? So now I see my a is going to be 1, b is negative 99, and all of this is c, right? So back to our discriminant. This one says one real solution, right? So we want to take our b squared minus 4ac and equal to 0. So it's going to be negative 99 squared minus 4 times 1 times 2,500 minus k equals 0. Remember, we won't solve it because we're using k. Change that to x. Zoom out. Here's our answer. 49.75 is what k is. Now, always make sure you reread the very last part of a question. A lot of people will get that far and still get it wrong because they'll get too excited and enter that in. But what did the question want? What is 4k, right? So we're going to take 49.75, multiply that by 4. There's our answer, right? So make sure you always glance at the very last bit of the question, okay? That's it. Next one. All right, similarity is a big thing on this test, right? You got to know your similarity. ABC similar DEF, right? Angles C and F are the right angles. Okay, tan A is this. What's the value of tan E, right? Okay, so similarity. We can kind of sketch this out, right? So I will kind of draw this out. Let's go over here, draw these two triangles out. So that's one side. Let me make this other side, and then third side. Okay, cool. So we got one triangle. We'll label it in a second. Make another one. So they could be different sizes. We don't know, right? They said C and F, I believe, were the right angles, right? So C and F. And so I can go something like this. I can go A over here, and then B over here, and then same thing over here, D, E, F, right? Oh. There it is, D, E, F, right? Okay, so C and F were right angles. That's what you got to make sure you get right. Otherwise, that was D, E, F. Okay. If you get the right angles wrong, that's the only way you can mess it up, right? Anyways, right, what we need to know with similarity, they tell you tan A, 1160, right? Here's the thing about similarity you want to know, right? 3 properties. The first 2 don't really matter for this question, actually. Corresponding angles are equal, corresponding sides are proportional. Here's the really useful one, right, in like a hard problem. Corresponding angles have the same trig ratios as well, right? So you see, when they tell you tan A is 11 over 60, it's the same as telling you tan D is 11 over 60, right? And that's what I'm going to fill in, right? So opposite of D, 11, adjacent to D, 60, right? And the reason I'm doing that is because the question's about E, right? So I want to know the numbers in this triangle. And that's the hack, right? You got to know that thing about similarity, right? That the corresponding angles have the same trig ratios, right? So it wants to know what is tan E, right? So from E's perspective, what does it end up being? Just opposite is now 60, adjacent, so 11. So it's actually a really easy problem, right? If you know that. Otherwise, people are going to think like, well, what's the proportionality or whatever? It doesn't matter, right? That's the truth. Because like, let's say this was even double, right? If it was double, if this was like 120 and this was 22, when you reduce it, it's still going to reduce to be the same, right? That's why they don't tell you, because it doesn't matter. So just remember that thing. That's a pretty cool one about the similarity and trig combination. They like to ask that, and then that's an easy question, right? Next one here, function g, okay, is defined by this. What's the product of G2A and GA? This is really simple, actually, in my opinion. The only reason it would be hard is, again, it's kind of like we talked about it before, right? There's certain times where you can plug in a number for like a constant, and if you don't know that, then it'll probably be like a lot more difficult than it needs to be, right? So here you see, obviously I can't just ask it what's the product of G2A times GA, right? The product that, because it doesn't know what A is, right? We solve that in a really easy way. We just tell it A is a number, and you see I get my answer, it's 70. And you can see I can change it to 3, I can change it to -3, I can change it to -5, because the condition is just A cannot be 0, right? But we always get 70. So just know when you can plug in for those constants, it'll make your life easier. All right, we've seen this before already. Actually, this is just another conversion one, right? So 360 square feet, right? Ooh, it's a little different. You see, squares sometimes could be with the first unit and not the second one, right? So that's a little bit different. So it's like this feet squared over 1 hour, right? So now we got to change it to meters per minute, right? So let's do the meters, right? So it's 1 meter over 3.28 feet. We already talked about this, right? What are we gonna have to do? We're gonna have to square this, right? So that feet squared will cancel out feet squared. And then finally, it's hours. We want it in minutes, so it's gonna be 1 hour on top, 60 minutes on the bottom. And let me just write this all then, without 3.28, without the units, right? Square, and then times 1 over 60. So here's our correct answer, 0.56, right? Again, usually you see if I get rid of the squared, what do we get? We get 1.829. That's the trap answer A, right? So we know better, so we're not going to fall for that, right? But they almost always have that. So next question. Percents, once again, right? Literally just translate, right? A is 40% greater than B. A equals 1 plus 40 over 100 times B. That's one equation. Next sentence is another equation. C is 25% less, right, than A, right? Okay, cool. And then the last one, this is an equation as well. A lot of times the question's an equation. C is, so C equals how many times, so we don't know, times B, right? So we want to solve for X, right? What do we basically got to do to solve for X? We got to divide by B. So you see, this is really what we want. We want to do C divided by B, right? And it's basically telling you, like, you just need to know what B is, right? Because if you know what B is, it'll calculate A. If it knows A, it'll calculate C, so then it'll know A, B, C, so then you can calculate this for you, right? So you see, if I just tell it B is 4, right, I get my answer. It's 1.05 times that. You see, I can change B to be some other number, 40. The answer's still going to be the same, even though these change. Can change it to be something else, right? I don't know if it'll matter. Probably, I don't know. I don't think it could be negative, but, any positive number, you'll get the same answer every time, right? So 1.05 here. So there we go. Okay. Next one, circle. Okay, circle has a center 1, 4. Line T is tangent to the circle at 4, 0. Which of the following is also on line T? Okay, this is actually a little bit more interesting, right? So let's go here. Let's kind of sketch this out just so we can see what's going on here. So they gave us a point here at the center, right? Let me make that bigger. Why is that so small? Let me zoom in. Maybe that's why. There we go. Okay. So 1, 4, right? That's going to be, is that what they said? What did they say? Center was 1, 4, yeah. And then it's tangent at 4, 0, right? Okay. So on a graph, right, what would that mean? If we're at 1, 4 over here, right? 4, 0, it'd be kind of going to the right and down. So we'll say it's over here, right? This is our point, 4, 0. All right, tangent's an important word, right? Like if we connect this obviously makes like a radius, right? And tangent's an important word, right? What tangent means is just you're touching the circle at that one point, right? So that's what a tangent line would look like, right? Now, another thing that's important to know is like when you have a tangent line, right, it's going to be perpendicular with the radius, right? So that's the whole key to this one, right? I can figure out what the radius is I can figure out what the slope is for the radius here, and then the tangent line is going to have a slope that's perpendicular to it, right? So that's it. I want to know the slope, right? So you can do the slope calculation yourself. It's not too bad. Or remember, you can just kind of put this in here, and Desmos will just kind of put out our slope, right? So our slope for the radius is -4/3, right? If you know what that is as decimal, that's great. So the one with the tangent line has to be the opposite reciprocal. It's 3/4, right? So this line is aligned with the slope 3/4, right? And then finally the question is, which of these points is also on line T, right? Basically, you need to know the equation of line T. So it's going to be y equals 3/4 x plus b, right? And then if I want to figure out b, well, I know this point is on there. I can just kind of plug that in, right? So if I plug that in, it would be like this times 4. So this is just going to be 0 equals 3 plus b. So b is -3. So my equation then, right, is just going to be this: y equals 3/4 x, right, minus 3. So that's going to be this tangent line, right? And basically then they're just asking us which equation, right, or which point is also like on this line, right? Well, if you have the line now, let me ignore this other line. If I have this line here, right, well, I can just kind of plug these points in and see if they're literally on the line. And there you go, right? A, first one, it is on the line, right? If I show you the other ones, they're not going to be on the line. That's B, right? If we try 0, 4, there it is. That's that point. It's not on the line, right? But we already know it's A. That was actually a pretty tough one, I feel like, right? So you got to kind of just know this relationship. Tangent to a circle, right? It forms a right angle. Sometimes, in fact, I think every time that's going to be the key really to kind of like solving those. So next one. Table shows 3 values of x and their corresponding values of y. F of x plus 7 is a quadratic function. Okay. All right. So yeah, they're telling us it's a quadratic function. So, you know, go back here to my table. Let me just change these points. 3, -2, 7, 30, 11, -2. So the thing is here, you do want to do a quadratic regression, but you got to be careful about what they're showing you, right? So got to read this carefully. This is for y equals f of x plus 7, right? So this is a transformation. You got to catch on to that. It's telling you these points, right, is the result of us taking f of x and moving it up 7 units, right? So if you do the quadratic regression for this, you're not going to get the right equation because this is f of x shifted up 7, right? So what do we got to do? We got to shift it, you know, take these points and shift it down 7 to just have f of x, right? I hope that makes sense. But shifting down 7 is easy. We're just going to subtract 7 to all the y coordinates. So it's going to be -9, 21, and then -9. Then we can do our quadratic regression, right? We get this, right? So did I enter in everything correctly? Because that looks a little bit weird for the y-intercept. The y-intercept should be this, right? This one, I did 30 down 9 units, that's why. So there we go. I was going to say, usually it's going to be like an integer. So this is it. This is your y-intercept when it's in standard form, right? If you, or you can zoom out and just click on it, right? But that's it, -75 for the y-intercept. Next question, similarity again. We talked about this. Okay, cool. It says ABC is similar to DEF, C and F are right angles. So we could basically kind of reuse this picture. That's perfect. Okay. It says AB is 3 times DE. So here they do give you the proportionality, but like we saw in the other one, it doesn't actually matter, right? So you see, they tell you tan A is 7/24, and they want to know what is sine D, right? So here we go. Let me get rid of this. So we know tan A is 7/24, right? But again, then they're going to ask us about D, which is in this other triangle, right? So instead of thinking about tan A being 7/24, right, I'm going to think about tan D being 7/24. So 7 for the opposite side, 24 over here for the adjacent side. And then you go ahead and do Pythagorean theorem, or you might know this, it's a triplet, 7, 24, 25, right? So that's going to be it. And it wants to know what sine D, right? Now we have all the sides, it's opposite over hypotenuse, right? That would be it, right? So here, yeah, they do tell you the proportionality, but then, you know, you see, if you were going to actually use that, it would make kind of like these numbers look really weird, right? Because you got to like, it said AB is 3 times DE, right? So we'd have to like divide them by 3. Ignore this picture. This triangle's bigger, but it should be smaller according to this problem. But again, you can ignore that, right? Just know that kind of property we talked about with the similarity triangles. There it is. Next one, another percent one, right? Okay, cool. A is 200% of B. Okay, so that's literally just, you know, this, right? Notice this one doesn't say increase or decrease of a percent, right? So it's literally just percent times whatever, right? And then you see A is 40 times C, right? 40 over 100, 40%, sorry. And then even the question again, it's in equations, C equals P%, so P over 100 times B. Question wants to know what is P, right? You do a little bit of math here. You see you can solve for P. P is just going to be 100 times C and then divided by B, right? So if I want to figure out P, I just got to know what C and B are basically. I'll get rid of this one, that's redundant. But I need to know what C and B are, right? So you see both of them kind of depend on A in this case, right? So I'm just going to rewrite this equation so that, it's in terms of, B, it's like B equals instead, which just requires us multiplying by the reciprocal. So it'd be B equals 100 over 200 times A. And then over here, same thing, C equals 100 over 40 times A. Now you see, I can just tell it A is like 5, right? And then it'll calculate everything. Calculate B, calculate C, calculate P. That's it. Now you see, I can change, the value of A. You see, I'm changing it. These numbers are changing for B and C, but my final answer is always the same because it doesn't matter really, right? As long as you get the relationships correct, that's it, 500%. Next one, equivalent. We talked about this before as well, right? This one's a little different. Here, if you type this in, you're not going to see like an equation, right? So if I type this in, I don't really get an equation here. Right? Sorry, it's not an equation, but I don't get a graph, right? The first one we saw, we got a graph, right? And we just matched the int choice with the graph. You're not getting a graph here, 2 reasons, so you're familiar with Desmos. Again, for a graph, Desmos just wants to see x if it's an expression, or you can have x and y if it's an equation, right? So here we got k and a, right? What I would do here, you can change this so you see a graph, but honestly, I would do something like this. I would just tell it a is like 2, k is 3. And now you see, I know the value for this expression is 162. One of these should also give me 162, right? So really simple, I just go through and put in each one. So it's not A, right? Let's check out the next one. 6K, 1 plus 4A, 162, there it is, right? And we're done, right? Simple. You don't have to do any math. You don't have to wonder, did they factor this? What did they do? Did they get a common denominator? Who cares what they did, right? We just need to find the match, right? That's it. Next one, another similarity problem, right? But this one's about proportionality because it's talking about area, right? Area of ABCD is 2700 and area EFGH is 300, right? So the area is 9 times bigger than this one, right? You got to know this proportionality. They love this for like a hard question, right? Here it is. It's kind of in your geometry section. If your sides are 3 times bigger, oh, this is perfect. It has the same numbers as well. Check this out. We got rectangles. This is beautiful. If I have these 2 rectangles, right, so let's say these dimensions are 2 and 5, right, and I triple the sides, 6 and 15, you see, what happens to the area, right? The area wasn't 3 times bigger. The area ended up being 9 times bigger, right? So we're using this concept just kind of like a little bit backwards. We know the area is 9 times bigger. What's that going to tell us about the sides, right? Well, the sides are 3 times bigger, right? Why is that? Well, area is like units squared, right? So the proportionality gets squared. If it was volume, you might see one with volume, right? It's units cubed, right? It could be, 3 times bigger or cubed times bigger, right? So it'd be like 27 times bigger in this case if we're talking about volume. But basically you got to know area is 9 times bigger, so the sides are 3 times bigger, right? In the bigger triangle. So you see, they tell us the longest side of, sorry, it's not a triangle, rectangle. The longest side of this rectangle is 90. They want to know what's the longest side of the other rectangle, the smaller one, right? Well, it's just divided by 3 then, right? Because again, the sides are 3 times bigger if the area is 9 times bigger. So I hope that makes sense. You want to know that. I've even seen volume, right? Once you know that, these are pretty simple, right? Okay, 22. This looks pretty similar. It is similar, okay? It's about triangles now. All right, so you see, now they're telling us about the sides. Sides are 6 times bigger, right? So in ABC, the sides are 6 times bigger than DEF, right? What is that going to tell us about area, right? So that means area is going to be 36 times bigger. So the area of ABC is 36 times bigger than the area of DEF, right? They want to know the area of DEF. So all we do, we take 540 and divide by 36. That's it. That's simple, right? If you know the proportionality, these are piece of cake. You don't have to figure out the sides or whatever, right? It's that simple. Make sure you know that because, these are pretty common. And when you know this trick, you see these are really, really quick. That was a great follow-up question, actually. Next one here. We got our equations and now it says infinitely many solutions, right? We did a couple that was no solutions, right? Here's infinitely many solutions. Literally means they're identical, right? As equations, they got to be the same exact equation. Same slope, same y-intercept, right? So literally both sides of the equation have to be the same. I feel like this is actually a lot simpler, right? You just need to remember, like, they literally got to be the same. On the right side, I'm going to simplify it a bit. I'm going to divide by 8. That'll leave us with 4x plus 6, right? So what do you know, right? Well, for the slope has to be the same. So right away, you see, you know, r has to be 4, right? So I'm just going to throw in, let me actually write that on the next line so we can keep track. R is 4, right? But the question's not about r, right? So what can I do next? Next, I just got to distribute, right? So it'd be s over 9 plus 4x minus 20 equals 4x plus 6. So you see, we've already matched the slope parts together. But, you know, with infinite solutions, what do we say? Same slope and same y-intercept, right? So the y-intercept over here is 6. It has to equal the y-intercept on this side, which is everything but the slope, right? So it'd be like this. S over 9 minus 20 has to equal 6. Now, just to get Desmos to solve it, just change s to x, right? There it is. Zoom out. Here's our answer, 234. Let's try that. That should be it. Yep, nice. And the last one here. We saw this as well before, right? So a couple repeats, right? Or similar things, right? We got to pick the correct linear equation, right? If you remember the first one, this should be easy. Remember the easy trick I told you is just find a point you can plug in right here. $65 for the first day, right? D is days, right? So that means if I plug in 1, first day, D is 1, I should get 65, right? So that's not going to give me 65. If I plug in 1 here, that's not going to give me 65. If I plug in 1 here, that's going to give me 65, right? That's it. It's literally that easy if you can recognize these problems, right? That's the whole thing. It's developing problem recognition, right? So here's the other way, like I said, you can just kind of put this in Desmos. If you want a linear equation, just give it 2 points, right? And the second point here is a little trickier, but it tells you it's $30 for each additional day. So if I wanted 2 days, it'd be $35 or $30 more, so it'd be $95. And there you go. I just get my regression that way, and that's it, right? So that's it. Those are 24 pretty hard questions, right? And let's check it out. Yeah, well, we saw we got everything correct, right? So yeah, you can try it yourself, right? If you can do well on these, honestly, there's probably scoring, you know, at least 750 or better, right? These aren't necessarily, I'd say, like the hardest ever problems you'll see, but honestly, they're hard problems that show up regularly. You got to know them. If you don't know these, then, well, you know, you're just not going to be in like the 800 range anyways, right? So you can try the diagnostic quiz, see how you do, right? It's going to tell you like if there's any particular subtopics of these domains that you got to focus on, right? And you could go ahead and practice it. You know, you should get different questions. It is randomized, but there's like 4 or 5, you know, variations of each question in here, right? So you shouldn't see the same numbers as I did, right? And then afterwards, you can kind of watch an explanation on any one of these. Just click the video explanation, and I have some pre-recorded here of me describing like how these would be solved, right? So that's the diagnostic quiz. Hopefully you learned something. If there's some subtopics you want to practice on, right, just jump over to the practice section then, and you can just literally click on anything, right? Jump in and like hammer these hard problems, right? And you should see similar things. And again, everything just kind of comes with video explanations. You could try it again after watching kind of like a video explanation. This is all designed just to be, in fact, here's a great example. It's basically the same kind of like proportionality idea we talked about, right? So if you didn't get it, watch the video, and afterwards you can just try it again, right? And again, each problem set has like 5, 6 different iterations. So if you go through it and exhaust all the problems, right, you should really be kind of like prepared for whatever's there. And then if you want, you can also do a practice test, right? This is something new to Sigma Prep, right? So we've taken the Blue Book test that they have and pretty much just made a new version of it, right? So let me jump here into mock test 4, right? You're gonna see module 1, module 2, whatever, all of the stuff, the same kind of questions, but different numbers, changed very, very subtly, right? But it's basically another one. So, you know, it's kind of annoying if you want to do practice tests, but it's the same practice test every time, right? You kind of don't know if you really know it or not just because it's the same questions, right? So the idea here is like if you took Blue Book test 4, you can kind of retake it with a different number and see if you're kind of solving them correctly, right? Just kind of go through both your modules here, and at the end, same thing, you'll kind of get like a little breakdown of what specific domains you need to work on and what specific subtopics you need to work on, right? So it definitely helps you kind of like identify like what areas and practice you really want to kind of focus on, right? So that's what we got here at Sigma Prep. So yeah, check it out. I hope it helps. It's helped a lot of people so far. So, you know, sign up, let me know what you think, any feedback, and let me know what you'd like to see next.